Algebra lesson 8-2. Now that we've looked at exponents and how some of the relationships of products of power and power of products and powers of powers, we want to look at a couple of special scenarios that a lot of people tend to get confused with and not quite understand. Some of the, they're easy, but there's also some confusion to them, and that's zero and negative exponents. What to deal with, or what to do with zero and negative exponents. To start with, any non-zero number, and any non-zero number means it just can't be zero. So that means it can be positive, it can be negative, it can be a decimal, it can be a fraction, it just can't be zero. To the 0th power is always 1. It's always going to equal 1. So it doesn't matter what the number is, if it's to the 0th power, it's 1. Yeah, but what if it's a million? A million to the 0th power? Yep, it's 1. If your goal in life and you're hoping later on is to have one child, then you could tell people you'd like to have 1 million to the 0th power children, and you'd really be telling them that you want one. You would actually want one kid. That's all you want out of the deal. Now, if I look at some examples, our numbers are based on 10. So 10 to the 1st power is actually a 1 with 1 0, or 10. 10 to the 2nd power is actually a 1 with 2 zeros. So there's your 2 zeros, there's your 1, 1 0. 10 to the 3rd power is a 1 with, you guessed it, 3 zeros. And 10 to the 4th power is a 1 with 1, 2, 3, 4 zeros. Alright? So then if you have a 10 to the 0th power, it can't equal 10. This was a 10 to the 1st power was a 1 with 1 0, 1 0. 2 zeros, 3 zeros, 4 zeros. So wouldn't this mean a 1 with no zeros? And there you have it. So it fits the pattern of multiples of 10. 10 to the 2nd power really means 10 times 10. So that's why it's 100. The other part is the negative exponents. And this is actually the reciprocal of what it would be if it were positive. So you got to think about, if I had a to the negative 5th power, it would be very similar to a to the positive 5th power. It would just be the reciprocal of that value. So here we have a to the negative n. If you want, you can draw a 1 underneath it. And then all you have to do is flip this, and it becomes a positive exponent. You just can't have a be a 0. This is for non-zero numbers. All right, for non-zero. And that actually works back here, because in reality, if you had 10 to the negative 1, then it's 0.1. And that's no different than 1/10. Now, here's a positive 1 and here's a negative 1. According to what we just talked about with the negative exponents, this answer should be the reciprocal of this answer. And how do you write 10 as a fraction? You write it 10 over 1. So isn't the 10 over 1 the reciprocal 1/10? So these are just reciprocals of each other. All right? 10 to the 2nd power, or negative 2nd power, is 0.01, which is equal to 1/100th, because the 1 is in the hundredths place. If you write this as a fraction, 100 over 1 is now 1 over 100. 10 to the 3rd, negative 3rd, 0.001, which you guessed it, is 1 over 1,000, which is the reciprocal of 1,000. And 10 to the negative 4th power, 0.0001, which is the same as 1/10,000, which is no different than 10,000 as a reciprocal. So there's a connection between these two. They are reciprocals of each other, reciprocals of each other, reciprocal, reciprocal. And there is no such reciprocal for this, as they just equal 1. So that's the relationship. It's all based on the concept of 10, since our number is based on 10. So let's try some out. 3 to the negative 4th power. One suggestion I have is you make it a fraction, which then tells you can reciprocal, make that 1 over 3 to the 4th power. So you can either leave it as 1 over 3 to the 4th. Notice that the base does not change signs. If it's a positive, it stays a positive. Only the exponent is changing signs. 1 over 81. 3 to the fourth power is 81. All right, negative 5.2 to the 0th power. As long as it's not 0, anything to the 0th power is 1. So that makes it quite simple. 4 to the negative y. Again, I'd make it a fraction. We know we want to look for the reciprocal. So it becomes 1 over 4 to the positive y. The exponent was negative, now it becomes positive. All right? A little trickier. It's already a fraction. It's got negative 1. But if I want to make it a positive 1, I have to flip the fraction. So this would become 5 to the 3rd to the positive 1, which really just makes 5 to the 3rd. Rewrite with positive exponents. So I'm only going to deal with the negative exponents that might be here. 4 is being multiplied by 3 to the negative k. All right. There's a multiplication sign in here. So I'm going to make each one a fraction. And I am going to take just this one and flip it. So I'll end up with 1 over 3 to the positive k. Biggest mistake is people think I should flip the 4 over 1. But there's no negative exponent on the 4, so it stays 4 over 1. And then fractions multiply straight across, so I get a final answer that is 4 over 3 to the positive k. Only the portion that had the negative exponent flipped down below. The 3 does not ever change signs. Only the exponent will change signs. Got to be very careful about that. People sometimes change the wrong pieces. All right? There are actually 3 terms here, or parts. 5, g to the negative 3h to the negative 4. Multiplication in between each of them, so I can make them all fractions. Only the stuff that is negative is going to flip and go down below. This 5 does not have a negative exponent. It will stay 5 over 1. But this will become 1 over g to the 3rd, and this will become 1 over h to the 4th. And then fractions multiply straight across, so your final answer is 5 over g cubed h to the 4th. Five didn't move, these didn't change signs, only the exponents changed size when they went down below. Okay, evaluate. Now there's 2 ways you can do this. This is power of, you got product of powers, they have the same base. So you could look at that and you could say, well, that's 4 to the negative 3 plus 3, which means it's 4 to the 0th power, which makes 1. Or you could take this and you could say that's 1 over 4 to the 3rd power, because now it becomes a positive, it's the reciprocal, multiplied by 4 to the 3rd over 1, which means they're going to cancel and they're going to cancel. You're left with 1 over 1, which is 1. The nice thing about math is you can get there from different ways and it still backs each other up. For me, I think it would probably be easier just to add the exponents since you're dealing with the same base. Okay? Now this is power of a power. And we had learned before that we're supposed to take the exponents and multiply them, so that's going to make negative 2 times negative 3. So we end up with 5 to the positive 6 power. Alright, rewrite with positive exponents. Multiplication here, make one a fraction, make that one a fraction. Now the 4 doesn't flip. 4 stays the same, but the y to the negative 3 becomes this. Fractions multiply straight across, 4 over y to the 3rd power. Biggest mistake I see on this problem is people also flip the 4, or they make the 4 a negative. Don't do anything to the 4, it's already got positive. Alright? In this problem, that whole thing is going to need to flip up above in order to become a positive exponent. So we will flip this, and we end up with g to the positive 2n over 1, which actually just makes g to the positive 2n. You don't need the 1 underneath. As an introduction to exponential functions, y is going to be equal to a times b to an exponent of x. Now that's different than y equals mx plus b. If you have growth, it'll make a curve like this. And if you have what we call decay, it's the flip of that, it's going to be going down. It'll get smaller. This is an exponent, not just multiplication. All right. Now, these are some links to YouTube that you could check out that are related to these exponential growth. We're going to make one of our own. So we have a graph of y equals 4x. And you get to choose anything you want. I'm going to go -2, -1, 0, 1, and 2. As I substitute those values in, remember 4 to the positive second power is 16. Because 4 times 4 is 16. That means that this is the reciprocal of that. It's 1/16. Because the negative version is always the reciprocal of the positive. 4 to the first power is 4. So that makes this one 1/4. And anything to the 0th power is always 1. I can now make a graph of that. I've got to get up to 16. I don't quite have enough to do, I can just count by those numbers. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16. There's 8. Across the bottom I've got plenty of room. 1, 2, 3, 4, 5. So there's 2. There's 1. So we can make -1 and -2. So I can make this a good sized graph. At 2 I'm at 16, which is here. At +1 I'm at 4. So 1, 2, 3, 4. At 0 we're at 1. At -1 I was at 1/4. And at -2 I'm at a 16th, which isn't quite 0, it's just barely above the x-axis. But what you can see is we get exponential growth. Now, over here, this value is never going to actually become 0. The next one is going to be 1/64th, and so on and so on and so on, as we get closer and closer and closer to 0, but we never actually become 0. Use an input-output table, and it's pretty easy. Look at some negatives, look at some positives. Remember, the negatives are just the reciprocal of whatever the positive.